Chapter 3, Expressive Data Modeling, Records, Sealed Types, and Pattern Matching. Chapter 3, Expressive Data Modeling, Records, Sealed Types, and Pattern Matching, is about using modern Java to describe data more clearly, with less ceremony and stronger guarantees. These features matter because a lot of enterprise Java code is not difficult because the business domain is complex. It is difficult because the code uses too much boilerplate, too many weak conventions, and too few explicit constraints. For many years, Java developers modeled simple data structures with ordinary classes. A request object, response object, event payload, or value object often needed fields, constructors, getters, equals, hash code, and toString. Most of that code did not express business meaning. It was mechanical structure. The more of it you write by hand, the more room there is for inconsistency, accidental mutability, and maintenance noise. Records solve that problem for simple immutable data carriers. A record says this type is mainly its data. The fields are final. The constructor, accessors equality, hash code, and string representation are derived from the declared components. That makes records a strong fit for DTOs, API contracts, event payloads, query results, configuration snapshots, and small domain values where identity is based on content rather than object identity. The important point is not that records save typing. The important point is that records communicate intent. When a senior engineer sees a record, they immediately know that this type should behave like a transparent, immutable value. That reduces cognitive load. It also reduces the temptation to hide business state changes inside objects that should simply represent data. Records are not a replacement for every class. If an object has complex lifecycle rules, mutable internal state, lazy loading behavior, framework-specific proxy requirements, or rich domain behavior, a normal class may still be the right choice. For example, JPA entities are often not ideal record candidates because persistence frameworks usually expect identity, lifecycle, and sometimes proxy behavior. Records are excellent when the data shape is clear and stable. They are less useful when the object is more than a value. Sealed types solve a different modeling problem. They let you define which classes or interfaces are allowed to extend or implement a type. That is powerful when a domain concept has a known set of valid alternatives. Instead of saying anything can be a payment command or anything can be a shape, we can state the permitted implementations explicitly. The model becomes closed where it should be closed. This matters because many bugs come from allowing impossible states. If a workflow can only be pending, approved, rejected, or canceled, the code should ideally express that. If a command can only be create customer, update customer, or deactivate customer, the type system should help enforce that boundary. Sealed types make the allowed variants visible and enforceable. Pattern matching then makes working with these variants cleaner. Instead of writing defensive casts, nested if statements, and scattered instance of logic, Java can inspect the type and bind the matched value more directly. Combined with sealed hierarchies, pattern matching gives us a safer and more readable way to process known alternatives. The code becomes closer to the domain. When this is a circle, calculate area this way. When this is a rectangle, calculate it that way. Together, records, sealed types, and pattern matching form a practical modeling toolkit. Records describe simple immutable data. Sealed types describe controlled variation. Pattern matching describes how we handle that variation safely. Used together, they let us express business rules with less noise and fewer accidental escape routes. A good example is an event-driven system. Events are often immutable facts. Customer created, payment captured, shipment delayed. Each event has a clear data shape, so records are natural. The set of events within a bounded context may be controlled, so a sealed interface can define the permitted event types. A consumer can then use pattern matching to handle each event explicitly. This gives better clarity than a loose hierarchy of mutable classes with string-based event names and manual casts. The same idea applies to API contracts, validation results, command models, rule engines, workflow states, and integration payloads. The goal is not to use modern Java features because they are new. The goal is to make the model harder to misuse. Senior engineers should ask, what states are valid, what variation is allowed, and what should be impossible. There are trade-offs. Sealed hierarchies are best when the set of variants is genuinely controlled. If external teams or plugins need to extend the model freely, sealing may be too restrictive. Records are best when immutability and value semantics fit the problem. Pattern matching is best when it improves clarity, not when it becomes a large procedural switch that replaces good polymorphism. The senior takeaway is that expressive data modeling is about reducing ambiguity. Modern Java gives us better tools to say what something is, what forms it may take, and how it should be handled. That makes code easier to read, easier to test, and safer to evolve. Use records when data should be simple and immutable. Use sealed types when the allowed alternatives are known. Use pattern matching when handling those alternatives should be explicit and clear. Together, they help Java code move away from boilerplate-heavy object modeling and toward clearer, more intentional domain design.